Hello, this is Mr. Huff. Let's take a look at these two formulas for displacement using the mechanics section of your engineering formula chart. The first one is the distance is equal to the initial distance plus the product of the initial velocity times time plus 1/2 acceleration times time squared. Only the time is squared in this formula. The second one is the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in displacement, or the final distance displacement minus the initial displacement. Alright, so that's how they're shown on the engineering formula chart. Let's go ahead and replace the d with either a y or an x. So you can be thinking about, is this moving up and down or is it moving left and right? Because you need to remember that y is not x. Keep that in mind. So this is what those formulas might look like. So this one is the one that lets you find a displacement using velocities, times, and accelerations. And this one lets you find a displacement if you know velocities and accelerations. So let's take a look at this scenario. This is a real common kind of problem you'll see in physics classes, where you have a person standing on a cliff and they have a ball or a rock or, small kitten or something that they're going to drop off of this cliff. And we want to know something about the displacement. So one of the things we can do, we can start with the initial displacement. We can say that the initial displacement is 0 because that's where this is starting. So where this ball starts, we're going to say that's 0, and that lets us get rid of initial displacement. The other thing we can do is we can look at this ball and we can see that that ball at the very beginning is not moving, so we can say that that is equal to 0 meters per second, and that means we can cross this whole chunk out. So we're left with, and the other thing we can do is recognize that A could be equal to gravity, and that lets us switch that A to a G. So they could be Y is equal to gravity times time squared divided by 2, or 1/2 gravity times squared. These two formulas are exactly the same thing. I prefer this first one because it's easier to manipulate algebraically. Let's think about a problem like this. So we have an initial velocity of this bicycle. So this bicycle is moving at 3 meters per second. It's going to reach a final velocity of 12 meters per second. It's going to accelerate uniformly at 1.5 meters per second squared. And we want to know how far the bicycle moves to reach that velocity. So we're going to use this formula, v squared equals vi squared plus 2ax. And we rearrange that using a little bit of algebra to get x by itself. So we have the final velocity squared minus the initial velocity squared divided by 2 times the acceleration. We plug those numbers in, just like this. 12 squared minus 3 squared divided by 2 times 1.5. And you plug that into your handy-dandy calculator, and you get a displacement of 45 meters. So that's an example of how to use that first formula. Some things to think about: if you know the time, or you're looking for time in your problem solving, you need to use this formula because it includes time. If you only know the displacements but you don't know anything about the time, then you need to use this formula over here because it does not care about time, only distances. So let's take one more look at that problem that I showed you earlier. We've got a person holding a ball over the edge of a cliff. We're going to say that this is his initial position, and we're going to call it 0 meters. And then we're going to say it has an initial velocity of 0 meters per second because he's just holding it. So that lets us get rid of the first two terms in our formula and reduce it to gt squared over 2. So if I drop the ball and it falls for 7 seconds, how far does it fall? So we plug in the numbers, minus 9.81. Oh, this is a negative number, it's moving away. 9.81 times 7 squared divided by 2. You get negative 240.3. Sorry, I left the little negative sign out because it's moving from 0 and it's going down in the y direction. It has a negative y displacement if the ball is at 0. It's real important to think about directions in the Cartesian plane to help you keep track of the signs. Okay? And that's all I have for this.